Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about thermal expansion of solids. So solids will expand as they're heated, and the amount that they'll expand depends on three different things. It will depend on the original length. It will depend on the coefficient of expansion for that particular metal or solid, and it will depend on the amount that the temperature increases. So you will need to look up the coefficient of expansion for the material that you're working with. I just put three different materials here: steel, cast iron, and aluminum, and each of those has two coefficients of expansion. One is if you're measuring your temperature in Fahrenheit and you're finding the change in degree Fahrenheit, this is the rate of expansion per increase of degree Fahrenheit. Similarly, this will be the rate of expansion for steel per degree Celsius increase. You might see slightly different coefficients of expansion, for example, for steel, because there's different types of steel. And steel, the rate at which steel increases can change as the temperature increases, but this is the value that's typically used for steel when we're working in Fahrenheit, and this is the one that's typically used if we're working in Celsius. Let's write a formula for finding the rate of expansion based on those three things, and then let's do some examples. Our formula for finding the change in length of a solid, notice I use delta L as my symbol for that. Delta often means change, so change in length will be equal to the original length times the coefficient of expansion, so it will be whichever expansion for whatever material and whichever temperature, times the change in temperature. So like I said, that increase will depend on the original length, coefficient of expansion for that solid, and the change in temperature. We could solve for any of the values in that formula. Let's start off by finding the change in length. So our first question says, what is the increase in length of a 15-foot steel bar if the temperature increases from -10 degrees Fahrenheit to 150 degrees Fahrenheit? We're working with steel. We're going to use our coefficient that was outlined in that chart. You may see a coefficient of expansion written in scientific notation. So if you see 6.3 times 10 to the -6, to change it to a regular number that you can easily put into your calculator, you're just going to move your decimal point 6 places to the left. So you'd move it 1 and then have 5 zeros. So these are equivalent, so don't be thrown off if you see your coefficient written in scientific notation. I know my original length is 15 feet. You can have your length in any unit, and as a result, your change in length will be in that same unit. And our temperature difference will be the higher temperature of 150 degrees Fahrenheit minus the lower temperature of -10 degrees Fahrenheit. So that's a temperature difference of 160 degrees Fahrenheit. So be careful if you have negative temperatures. The difference from -10 up to 150 is an increase of 160 degrees. We plug those values into our formula. We multiply these values and we get 0.01512 because the original length was in feet, so will the change. This is such a small amount that we might prefer to write that in inches and round it off to the nearest thousandth of an inch. So we're going to multiply by 12. And we get our change in length equal to 181 thousandths of an inch. Let's try an example where we are going to find one of these values when we know what change in length we want. Our next example says at 50 degrees Fahrenheit, a shaft has a diameter of 20 inches, and the inside of a steel hub is 19.99 inches in diameter. To what temperature must the hub be heated as to step over the shaft with a clearance of 0.02 inches? So we have a circular hub that needs to go over top of a shaft, and that shaft has a diameter of 20 inches, and we need this steel hub to be greater than that by 0.02 inches. So we need the steel hub diameter to be 20.02 inches. Right now it's 19.99 inches. So we need to find, or we can find, the change in the diameter. So the original diameter is 19.99. So if we subtract, we get 0.03 inches. This is going to be our change in length, our change in diameter. We want to increase it by 3/100ths of an inch. So we know the change in diameter, we know the original diameter, we know the coefficient. What we're going to find is the change in temperature, and once we find that change in temperature, then we can find the new temperature. So now I'm going to plug into my formula. I know that the change in length needs to be 0.03 inches, or the change in diameter. The original diameter of that steel hub that I'm going to be heating up is 19.99 inches. The coefficient of expansion for steel and for degrees Fahrenheit is this one. And what we don't know is the change or increase in temperature. So there's two ways I can solve this equation. I could either multiply these two numbers together first and then divide both sides by that. So I'll do that one. I'll do that method first. I've written it to this many decimal places, but it's going to go further than that. So if you do it this way, you're going to want to be able to store that number in the memory on your calculator, because you're next going to want to divide by it. Now I divide both sides by that number, so 0.03 divided by that number. And if I divide by the number on my calculator rather than the rounded off one I wrote down, when I calculate it, I will get change in temperature will be 238.2. And that's not my new temperature, that's how much I have to change the temperature. So my original temperature was 50 degrees Fahrenheit. I have to increase it by 238.2 degrees Fahrenheit. So when I add those together, I will get 288.2 degrees Fahrenheit. So I have to heat up the steel hub by that amount, in other words, to a temperature of 288.2 degrees Fahrenheit. That will give me a hub with the correct diameter. The other way I could have solved this equation, and you might find this easier because then you don't need to use the memory function on your calculator, is you could have divided by each of these factors separately. It's similar to solving an equation like this. I could either multiply 2 times 3 and get a 6. So 24 is equal to 6x. And then divide both sides by 6 to get x equals 4. Or I could have divided by each of these factors separately. So I could have divided both sides by 2, and then I would get 12 equals 3 times x, because the 2's will cancel there. And now I divide both sides by 3, and I still get x equals 4. So you can either multiply these two numbers together and then divide 0.03 by that, or you can take 0.03, divide by 19.99, and then divide by 0.000063. If you do that, you are still going to get 238.2. So you choose the method that you find the easiest. So here's your equation for finding the change in length or diameter of a solid. Whatever unit your length is, that's what the change in length will be. Make sure you have the correct coefficient for both the material and the temperature that you're working in. And make sure you find the change in temperature correctly. And lastly, be able to manipulate the equation to be able to solve for any of these values if you know the change in length as well as 2 of these values.